Hello everyone, welcome to Infinity Learn by Sri Chaitanya. In this session, we will discuss physics paper, MPL physics paper, weekend test 12. My name is Vibhati Jain and let's start our session with question number 1. Question number 1 is, a satellite of mass m is revolving around the earth of mass capital M in a circular orbit of radius r. As the satellite moves from one point of the orbit to the diametrically opposite point, the magnitude of change in the gravitational force it experiences is, where capital G is universal gravitational constant. So let's say Earth is here of mass capital M. This is the circular orbit in which the satellite is revolving around the Earth of mass small m, and r is the separation between them. Then, if satellite is over here at point P, the force of gravity between Earth and the satellite will be in this direction towards the center of the Earth, and it will be GMM divided by r square. Now, when satellite moves from this position to this position, just diametrically opposite point to Q, then the magnitude of gravitational force will remain same, but direction will change. Okay, directions are exactly opposite. Why? Because at this point satellite was here, at this point satellite is here, and gravitational force is always directed towards the center of the earth, right? In this particular case. So direction will change, direction is exactly opposite. So if you take one direction as positive and other direction as negative, let's say initial direction is negative, final direction is positive, then change in force will be GMM divided by r square minus GMM divided by r square. So it will be 2GMM divided by r square. Right? We are dealing with the vector quantities. That is why it is important to specify direction also. So correct answer is option 2, that is 2GMM upon r square. Question number 2 is, a body is revolving very close to the surface of the planet. When the mass of the planet is suddenly reduced to half without any change in radius, then what happens to the body? So let's see. When mass is m, radius of the planet is r, then orbital velocity of this satellite body is under root gm upon r. Okay. Now, when we are reducing the mass of the planet by 1 by 2, its orbital velocity VO dash should be gm upon 2r, but it is under root gm upon r. Now, let's see for this second situation, what should be the escape velocity for the planet? So, VE dash new escape velocity will be 2 under root g m by 2 divided by r. So it is equal to under root g m upon r. So basically this velocity is equal to new escape velocity of the planet. So body will escape from the planet. So correct option will be option 2. Question number 3. The escape velocity on the surface of the planet of radius r and density rho is v. What will be the escape velocity on the surface of the planet of radius 2r and density 4 rho? We need to find new escape velocity if radius is 2r and density is 4 rho. So let's find the expression of escape velocity in terms of density first. So escape velocity VE is under root 2 gm upon r on the surface of the planet. You can write mass as density into volume. So this will be 2g. Density into volume of sphere is 4 by 3 pi r cube divided by r. So this r will cancel this r. It will become r square, and out of the square root sign it will become r. So it will be r times under root 8 by 3 pi rho g. So this is the escape velocity in terms of radius and density. In the first situation, it is v when radius is r and density is rho. When radius becomes 2r, let's say it is v dash and density is 4 rho. So this is the second situation, 2r into under root of 8 by 3 pi g into 4 rho. Let's divide these two expressions. So R will cancel this R. 8 by 3, 8 by 3 cancel, pi cancel, GG cancel, rho cancel. So we have V upon V dash is equals to 1 upon 2 under root 4. Under root 4 will be 2, so it is 1 by 4. Right? So V dash will be 4V. New velocity, escape velocity on this planet will be 4V. Option 3 is correct. Question number 4. Angular momentum of a satellite of mass m moving around Earth in an orbit, circular orbit of radius r is L. So angular momentum is mvr, where v is the orbital velocity of the satellite. So it will be m under root g m divided by r into r. So it will be m under root g m into r, where capital M is the mass of the planet and r is the orbital radius. Fine. Then what will be the angular momentum of the satellite of mass 2m moving around the earth in a circular orbit of radius 4r? So L dash will be 2m under root gm into 4r. So it will be 4 times m under root gm into r. So this value is the previous angular momentum. So L dash will be 4L. So correct answer is option 2. Question number 5. The distances of two planets from the sun are 10 power 12 meter and 10 power 10 meter respectively. The ratio of the time periods of this planet is. So you can apply Kepler's law of time period. So T1 square upon T2 square is equals to R1 cube upon R2 cube, right? So T1 upon T2 whole square can be written as R1 upon R2 whole cube. You can put the value of R1 as 10 power 12 divided by R2 is 10 power 10 whole cube, right? So this will be 10 power 2 whole cube, which is 10 power 6. So T1 upon T2 will be square root of 10 power 6, which is equals to 10 power 3. So ratio will be 1000 is to 1, which is option 1. Question number 6. Which of the following is true for a satellite in circular orbit? It is a freely falling body. Yes. Satellite performs its motion under the gravitational force. Gravitational force is responsible for providing centripetal acceleration, right? So yes, it is a freely falling body. Its speed is constant. Yes, it performs circular motion with the help of centripetal force g m1 m2 upon r square. So no tangential force is there, so its speed is constant. Right. Next is it suffers no acceleration. No, it suffers acceleration. It is an accelerated motion with constant speed because the direction of acceleration is always directed towards the center of the earth, right? And this arrow will change. If satellite is over here, direction of acceleration is this one. If satellite is over here, direction of acceleration is this one, right? And if satellite is over here, direction of acceleration is this one. If you look at the direction of velocity, it is continuously changing, and because of the change in direction of velocity, it is what? An accelerated motion. So yes, this statement is wrong. Next is it does not require energy for motion in the orbit. Yes, that is also true. Gravitational force is directed towards the center and its displacement vector is directed along the tangent, okay, of the circular path. So angle between force and displacement vector in this case is 90 degrees. So work done by gravitational force is 0. So yes, because of the presence of gravitational force, it will not have any extra energy, right? So correct statement is D also. So out of these four statements, A, B and D statements are correct. So correct answer will be option 2. Question number 7. A body released from certain height reaches the surface of the earth after t seconds. So you can find t as under root 2h by g. Right? If the same body is released from the same height on the moon, it reaches the surface after, where acceleration due to gravity on the moon is g by 6, where g is the acceleration due to gravity on the surface of the earth. So t dash, that is the time on the moon, will be under root 2h upon g by 6. So you can write it as under root 6 times under root 2h upon g, right? And under root 2h upon g is what? T. So it will be under root 6 times t. So time taken by the particle to come back to the surface of the moon will be root 6 times t, which is option 3. Question number 8. A child swinging on a swing in sitting position stands up, then the time period of the swing will be. So when child is sitting, its center of gravity is somewhere over here. Okay, center of gravity, let's say somewhere over here. When child stands up, because of the standing up, the center of the gravity shifted upwards, and because of that the effective length of the system, oscillating system decreases, and because of that time period will decrease. So correct answer is option 2. Question number 9. The orbital speed of a satellite moving in a circular orbit around the earth is equal to 50% of the escape velocity on the surface of the earth. Then height of the satellite above the surface of the earth is. So it is given in the question that orbital speed is 50%, that is 1 by 2 times the orbital escape velocity of the planet. Okay, 1 by 2 times the escape velocity of the on the surface of the earth, right? So we need to find the height of the satellite above the surface of the earth. So orbital velocity at a height h is given by under root g m upon r plus h, where r is the radius, m is the mass of the earth. 1 by 2 times escape velocity on the surface of the earth is given by under root 2 g m upon r. So let's square this relation. So it will be gm upon r plus h is equals to 1 by 4 2 gm upon r. You can cancel gm, this will be 2. So you can see that 1 upon r plus h is equals to 1 upon 2r. That means r plus h is equals to 2r and h will be r. So height of the satellite from the surface of the earth is equals to r, which is option 3. Question number 10. The amplitude of damped oscillator becomes 1 by 3 in 2 seconds. Okay. Its amplitude after 6 seconds is 1 by n times the original. The value of n is. So amplitude in damped oscillations is given by a naught e power minus gamma t, where gamma is damping coefficient. Okay. Over here it is given in 2 seconds, amplitude becomes 1 by 3 times the original. So A will be A naught by 3, which is equals to A naught e power minus gamma into 2. So you can write 1 by 3, A naught will cancel this A naught. So we have 1 by 3 is equals to e power minus 2 gamma. Right? Now we need to find the value of n if it becomes, amplitude becomes 1 by n times the previous one in 6 seconds. So for 6 seconds you can apply the same equation. It will be a upon n is equals to, a naught upon n is equals to a naught e power minus gamma into 6. So you can write 1 upon n is equals to e power minus 2 gamma into 3. So you can write this as e power minus 2 gamma to the power 3, right? But e power minus 2 gamma is 1 by 3. So 1 upon n can be 1 by 3 whole cube. So n can be 3 power 3, which is option 4. Question number 11. Two particles A and B of equal masses are suspended from two massless springs of spring constants K1 and K2 respectively. If the maximum velocities during oscillation are equal, the ratio of amplitudes of A and B is. So maximum velocity V max is given by A into omega. So for particle 1, it will be A1 omega 1. For particle 2, it is A2 omega 2. And A1 omega 1 is equals to A2 omega 2. So ratio of amplitude A1 to A2 is omega 2 divided by omega 1. Right? And you can write time period. In this case is 2 pi under root m by k, which is equals to 2 pi by omega. 2 pi cancel. So we can have omega as under root k upon m. Right, so for the first particle, you can write omega 1 as under root k1 upon m and omega 2 as under root k2 upon m. I'm not changing the mass because it is given of equal masses. Right, so omega 2 will be under root k2 upon m divided by omega 1 is under root k1 upon m. right? Cancel. So we have E1 upon E2, which is omega 2 divided by omega 1 as under root K2 upon K1, which is option 4. Option 4. Question number 12. The time period of a simple pendulum inside a stationary lift is under root 5 seconds. So time period of a simple pendulum is given by 2 pi under root L upon G, which is equals to under root 5 seconds. What will be the time period when the lift moves upwards with an acceleration g by 4? When lift move upwards with an acceleration a, its time period becomes L upon g plus a, right? So it will be 2 pi under root L upon g plus g by 4, which is equals to 2 pi under root 4L upon 5g. Okay, so you can take this 4 outside, so it will become 2 times 2 pi under root L upon 5g. You can take this under root 5 outside, so it will be 2 upon under root 5 into 2 pi under root L upon g. 2 pi under root L upon g is given as under root 5 seconds, so it will be 2 upon root 5 into root 5, which is equals to 2 seconds. So correct answer is option 4. Question number 13. A particle is acted simultaneously by two mutually perpendicular simple harmonic motions. X is equals to a cos omega t and y is equals to a sin omega t. The trajectory of motion of the particle will be. So actually we need to find the relation between x and y in this case. So let's square these two equations. So we'll get x square is equals to a square cos square omega t and y square is equals to a square sin square omega t. Now let's add these two equations. So we'll get x square plus y square is equals to a square cos square omega t plus a square sin square omega t. You can take a square common, so it will become cos square omega t plus sin square omega t, right? So cos square omega t plus sin square omega t will become 1 because of the identity sin square theta plus cos square theta is equals to 1, right? So technically what do we have over here? We have x square plus y square is equals to a square, and this is nothing but the equation of a circle, right? So the trajectory of motion of the particle will be a circle. Option 3 is correct. Next is question number 14. The displacement time graph of a particle executing SHM as shown in the figure. Which of the following statements is /r false? Okay. So you can see that displacement is maximum at t is equals to 0, at t is equals to t by 2 and at t is equals to capital T. That means particle is starting its motion from the extreme position, right? From the extreme position. So you can write equation as x is equals to a cos omega t. Okay. Now we need to identify the false statement. So the acceleration is maximum at t is equals to capital T. So acceleration is minus omega square x. Okay. X is maximum, then acceleration is maximum. X is maximum at t is equals to t, so acceleration will be maximum. So this statement is true. Force is 0 at t is equals to 3t by 4. This is 3t by 4 and this is 3 by 4. At these two locations, particle is at its mean point. Okay, right? So at these two locations, the value of x is 0. That means acceleration is also 0, right? So if acceleration at these two locations is 0, that means force is also 0. So yes, this statement is also true. Next is potential energy equals the total oscillation energy at t is equals to t by 2. At t is equals to t by 2, particle is at its extreme position. Again, displacement is maximum in the opposite direction, right? Okay. So when particle is at extreme 1, then over here particle will be at extreme 2. So again, bachcho, the potential energy is given by half kx square or half m omega square x square, right? So when the value of x is maximum, right, potential energy is maximum and kinetic energy is 0. So at t is equals to t by 2, you can see that particle is at extreme, so its kinetic energy is 0. So total energy, which is kinetic plus potential, So kinetic is 0. So total energy will be just potential only. Right. So yes, this statement is also true. Next is at t is equals to capital T by 6, potential energy is equal to kinetic energy. So at t is equals to capital T by 6, potential energy is equal to kinetic energy. So let's find what is the value of x at t is equals to T by 6. So it is x is equals to a cos. You can write omega as 2 pi by t into T by 6. This will cancel this and we have a cos pi by 3. Right, a cos pi by 3 is 1 by 2. So this is a by 2. Potential is half kx square, which is a by 2 whole square, which is 1 by 4 times half k a square. Right. So you can find kinetic as t minus u, which is half k a square. Total is always half k a square in SHM. Right. So it is half k square minus 1 by 4 times 1 by 2 k a square. So this is 3 by 8 k a square. So potential is 1 by 8 k a square and kinetic is 3 by 8 k a square. So potential is clearly not equal to kinetic, right? So correct statement. Correct answer is option 4. So this statement is false. So correct answer is option 4. Question number 15. A copper rod of 88 centimeter and aluminum rod of unknown length L have their increase in length independent of increase in temperature. The length of aluminum rod is. So technically delta L1 is equals to delta L2 because increase in length is independent of increase in temperature. What is change in length due to increase in temperature? It is L naught alpha delta T, where delta T is what? Change in temperature. Alpha is the coefficient of linear expansion, right? So in this case, it will be L naught for copper 88. Alpha of copper is 1.7 into 10 power minus 5. Delta T is equals to delta L2 for aluminum, which is length of the aluminum in initial length into alpha AL, which is 2.2 into 10 power minus 5 into delta T. This will cancel this. So we have L is equals to 88 into 1.7 into 10 power minus 5 divided by 2.2 into 10 power minus 5. So it will give you the length of the aluminum, initial length of the aluminum as 868 centimeter, which is option 1. Question number 16. Two brass rods of the same length, okay, but different diameters are heated by equal amounts of heat. The expansion is, so we have two brass rods, one of diameter, smaller diameter, and other one is of larger diameter, something like this. So this is the thin rod and this is the thick rod. Length is equal, right? Alpha will be equal, right? And amount of heat supplied, delta Q, is also equal, right? So change in length, delta L is equals to L naught alpha delta T. Okay. Now, we are supplying the same amount of heat, but nothing is given about the change in temperature, whether it is equal or not. So, we need to find change in temperature relationship for both the rods first. So, heat supplied is equal. Now, what is the value of heat supplied to increase the temperature by delta T? So, it is M S delta T, right? So, delta T will be delta Q upon MS. S and delta Q is same because material is same and delta Q is given same in the question only. So increase in temperature is inversely proportional to mass, right? But mass is density into volume. Now what is volume? Volume is area of cross section into length. So rho into A into L will be the mass. Okay. So delta T is inversely proportional to rho AL. Now rho and L is similar for both the materials. Material is same, so rho is same, L is given in the question same. So delta T is inversely proportional to A. Okay, delta T is inversely proportional to A. Okay, so if area of cross section is more, change in temperature will be less, right? So for this one, for thicker rod, change in temperature is less. For thinner rod, change in temperature will be more. Fine. And delta N is directly proportional to change in temperature. So for thinner rod, change in temperature is more. That is why the expansion will be more in the thinner rod, which is option 3. Question number 17. The ratio of the lengths of two rods is 4 is to 3. L1 upon L2 is 4 by 3. The ratio of the coefficient of cubical expansion gamma 1 upon gamma 2 is 2 by 3. Now we know that gamma is equals to 3 alpha. So you can write alpha 1 upon alpha 2 is equals to 2 by 3. Then the ratio of the linear expansion when they are heated through same temperature differences. So delta L1 will be L1 alpha 1 delta T and delta L2 will be L2 alpha 2 delta T. Now let's divide these two equations. Okay, so delta T cancel because same temperature difference. So delta L1 upon delta L2 is nothing but L1 upon L2 into alpha 1 upon alpha 2. L1 upon L2 is 4 by 3. Alpha 1 upon alpha 2 is 2 by 3. So it will be 8 by 9. I hope this is clear. Right. So correct answer is option 3. Next is question number 18. A steel meter scale is to be ruled so that millimeter intervals are accurate within about 5 into 10 power minus 5 millimeter at a certain temperature. The maximum temperature variation allowable for steel meter scale. So, maximum increase in length that we can have for delta T increase in temperature is 5 into 10 power minus 5 millimeter for 1 millimeter, right? So we need to find the corresponding temperature change in this one, right? So you can write delta L is equals to L naught alpha delta T. So delta T will be delta L upon L naught alpha. Delta L is 5 into 10 power minus 5 with L naught is 1 millimeter and alpha is 10 into 10 power minus 6. So corresponding to this, delta T will be 5 degrees Celsius. So correct answer is option 2. Question number 19. The density of a substance at 0 degrees Celsius is 10 gram per cc and at 100 degrees Celsius it is 9.7 gram per cc. The coefficient of linear expansion of the substance is. So density variation with temperature is given as rho is equals to rho naught into 1 minus gamma delta T, right? You can write gamma is equals to 3 alpha. So this is rho, which is at higher temperature 9.7, rho naught is at lower 10, 1 minus gamma is 3 alpha, delta T is 100 minus 0, so it is 100, right? So you can write it as 0.97 is equals to 1 minus 300 alpha. So 1.097 will be 0.03 is equals to 300 alpha. So alpha is approximately 10 power minus 4 or exactly not approximately 10 power minus 4 degrees Celsius inverse. So correct answer is option 4. Question number 20. A body has a charge of minus 4 microcoulomb. How many excess electrons the body has? So it is a negative charge. That means body has excess electrons. Let's say this charge is equal to n into E. So n is the number of excess electrons, which is 4 into 10 power minus 6 divided by E, which is 1.6 into 10 power minus 19. So you can write it as 1 by 4, 10 by 4 into 10 power 13. So this is 10 power 14 divided by 4, which is 0.25. So 2.5 into 10 power 13 is the number of excess electrons on the body, which is option 2. Question number 21. We have 5 balls numbered 1 to 5 are suspended using separate threads. Pairs 1, 2, 2, 4 and 4, 1 have electrostatic attraction, while 2, 3 and 4, 5 shows repulsion. Therefore, ball 1 must be. So, let's assume that ball 1 is positive. So, this should be negative because these pairs are showing attraction, right? So, this is negative, so it should be positive. If it is positive, then it should be negative, right? So, it is not possible if 1 is positive. Similarly, you can try this activity for negative also. You'll get 1 over here negative and 1 over here positive, which is not possible. So, it cannot have positive or negative charge. That means it should be neutral. So, correct answer is option 3. Question number 22. A charge Q is to be divided on two small spheres separated by a distance r. The maximum possible electrostatic force between the spheres can be. we have two small spheres separated at a distance capital R, and we have total charge Q, and we want to divide this total charge Q in such a way that the electrostatic force between these two spheres can be maximum. Right, so let's assume that we are giving x charge to the first sphere and remaining q minus x charge to the second sphere. So force will be k, which is 1 upon 4 pi epsilon naught r q1 into q2 divided by r square. So this is k qx minus x square divided by r square. Now this force should be maximum. That means its differentiation with respect to x should be 0. So let's differentiate this force with respect to x. Okay, so we need to find the differentiation of k qx minus x square divided by r square, and we need to put it equal to 0. So differentiation of, let's k upon r square as it is, let's keep k upon r square as it is. Differentiation of qx will be q only, minus differentiation of x square will be 2x, and it should be 0. So q is equals to 2x and x is equals to q by 2. So force is maximum when you distribute this charge equally, right? So this should be q by 2 and this should be q by 2. So maximum force will be k q by 2 into q by 2 divided by r square, which is k q square upon 4 r square, and that is option 2. Question number 23. When a body acquires positive charge, its mass decreases. Body is acquiring positive charge because of the transfer of electron from that body to another body, right? So it is losing electrons. That means its mass will decrease. So this statement is true. When a body acquires positive charge when it loses electrons, yes, that is also true. So both statement 1 and are correct. That is our correct answer. Question number 24. A force of 4 Newton is acting between two charges in air. So force in air is 1 upon 4 pi epsilon naught q1 q2 upon r square. If the space between them is completely filled with glass of relative epsilon is equals to 8, then new force will be. So F dash is 1 upon 4 pi epsilon into epsilon r q1 epsilon naught into epsilon r q1 q2 upon r square. So you can write it as 1 upon epsilon r into 1 upon 4 pi epsilon naught q1 q2 upon r square, right? So epsilon r is 8, so it is 1 upon 8 into 1 upon 4 pi epsilon naught q1 q2 upon r square is equals to 4. So it will be 4 into 1 by 8, which is 1 by 2, and that is our 0.5 Newton. So correct answer is option 4. Question number 25. We have two identical metal spheres with plus 60 coulomb and minus 20 coulomb of charges. They are brought in contact, then separated by 10 centimeter. So we have two identical metal spheres. So because of the contact, there's some potential difference between these two spheres, right? And because of the contact, because of potential difference, the charges will transfer from one sphere to the other sphere, right? And the charge will transfer till the potential becomes same, right? So since we have identical metal spheres, so we can say that the charge will distribute equally, है ना? Right? And after the charge becomes equal on both of these two spheres, the charge transfer will stop, right? So total charge is 60 minus 20, which is 40 coulomb. So out of 40 coulomb, 20 coulomb will be on first sphere and 20 coulomb on the next sphere, right? And the separation will be 10 centimeter, which is 0.1 meter. Okay, so force of repulsion will be k q1 q2 upon r square. K is 9 into 10 power 9. Q1 is 20, Q2 is 20 divided by r square, which is 0.1 whole square. So this is 36 into 10 power 9, 10, 11 into 10 power 2. So this is 36 into 10 power 13, or you can write it as, yeah, I think it is given in the option only, which is option 1, right? Question number 26. We have three charges, each equal to 10 power minus 9 coulomb, are placed at the corners of an equilateral triangle of side 1 meter. The force on one of the charges is. So we have this equilateral triangle, something like this, and we have three charges placed over here. 1, 2, 3. Let's say we want to find the force on this charge. Okay. So this is 10 power minus 9 coulomb. This is 10 power minus 9 coulomb. And this is also 10 power minus 9 coulomb. So force exerted by this charge on this charge will be repulsive force, same nature. So let's say this is in this direction, and force exerted by this charge on this charge will be repulsive. So this is F2. Now this angle is 60 degrees. So this angle is also 60 degree, right? Now what is the magnitude of F1? It is K Q1 Q2 upon R square. K is 9 into 10 power 9. Q1 is 10 power minus 9. Q2 is 10 power minus 9 divided by R square, which is 1 square. So we have force F1 as 9 into 10 power minus 9 Newton. Similarly, F2 is 9 into 10 power minus 9 Newton. You can calculate it. You'll get the same answer, right? So angle between these two vectors, F1 vector and F2 vector, is 60 degrees. So magnitude of the force will be, resultant force will be under root of F1 square plus F2 square plus 2 F1 F2 cos 60 degree. Okay, cos 60 degrees 1 by 2, F1 F2 magnitude same. So you can put F1 F2 is equals to F. So it is f square plus f square plus 2f square cos 60 degree, which is 1 by 2, cancel. So we have under root 3f, right? So resultant force on this charge due to the presence of these two charges, this one and this one, will be root 3 into 9 into 10 power minus 9 Newton, which is equal to option 2. Question number 27. Two insulating small spheres are rubbed against each other and placed 1 centimeter apart. Calculate the number of electrons transferred from one sphere to another if they attract each other with a force of 0.1 Newton. So because of the transfer of electron from one sphere to another sphere, what will happen? This sphere, let's say this sphere is transferring electron from this to this, so it will lose electrons. Okay, let's say it loses n electrons. So charge on this will be positive, and it is equals to loss of n electrons, which is plus Ne, and it gains electrons, right? And because of that, charge on this sphere will be negative, and it is equal to the gain in n electrons. So it is minus Ne. Now, force of attraction is given as 0.1, which is equals to 9 into 10 power 9 into Q1 Q2, which is Ne square divided by R square, which is equals to 1 centimeter. So it is 10 power minus 2 meter whole square, right? So you can write it as Ne square is equals to 0.1 into 10 power minus 4 divided by 9 into 10 power 9. So it is 10 power minus 5. It's 1 upon 9 into 10 power minus 40. Minus 5 minus 9. Okay. So Ne can be written as 1 upon 9 into 10 power minus 14 square root. So it is 1 upon 3 into 10 power minus 7. That is Ne, right? Now let's find the value of n. So it is n is equals to 1 upon 3 into 10 power minus 7 divided by E. What is the charge on one electron? 1.6 into 10 power minus 19 coulomb, right? So after solving this one, you'll get the approximate value of n as option 1, 2 into 10 power 11. Question number 28. The frequency of a particle performing SHM is 12 Hz. So omega is 2 pi f, which is equals to 2 pi into 12, that is 24 pi, right? Its amplitude A naught is equals to 6 centimeter. Its initial displacement is 3 centimeter towards positive extreme position. Its equation for displacement is, so it is given that its initial displacement is 3 centimeter towards positive extreme position, right? So we can assume that its equation x is equals to a naught sine omega t plus phi. At t is equals to 0, it is at 3 centimeter, a naught is 6, and sine omega t will be 0 plus 5. So 3 is equals to 6 sine phi will give you the initial phase, right? So sine phi is equal to 1 by 2, and it is possible when phi is equals to pi by 6. right? So equation will be x is equals to a naught sine omega t plus pi by 6 centimeter. We need to convert it into meter. So it will be 0.06 sine omega t plus pi by 6. So correct answer is option 3. Question number 29. The temperature of a thin uniform rod increases by delta T. If the moment of inertia be I about an axis perpendicular to its length, then its moment of inertia increases by. Okay. So moment of inertia I is, let's say, some constant k into ml square. Right? Now L is initial length, then new length L dash is L into 1 plus alpha delta T. Or you can write delta L is equals to L alpha delta T. Okay, fine. We need to find the moment of inertia, new moment of inertia, if the length increases, right? And this is the increase in length. Okay, so I dash will be K M L dash square. Okay, fine. I dash will be K M L dash square, right? Okay. Uh, so increase in moment of inertia will be I dash minus I, which is equals to K M L dash square minus Km L square, which is equals to Km. L dash square can be written as L square into 1 plus alpha delta T whole square minus L square, right? L dash square is L square into 1 plus alpha delta T whole square minus L square is L square. I'm taking Km outside. Okay, so you can write I dash minus I is equals to KML square into 1 plus alpha delta t whole square minus 1. KML square is what? Previous moment of inertia I. So it is I into, for small values of alpha. Alpha is approximately in the range of 10 power minus 4 to 10 power minus 5, right? So 1 plus alpha delta t, mein alpha delta t is much smaller than 1. So you can use the approximation over here, right? So you can write it as 1 plus 2 alpha delta t minus 1. 1 will cancel this 1. So I dash minus I will be 2I alpha delta t, right? So this is the change in moment of inertia, which is equals to option 3. Question number 13. A brass stopper snugly fits in the hole of steel pipe. To remove the stopper easily, the system should be heated, should be cooled, maybe heated or cooled, cannot be removed by heating or cooling. So we have steel pipe and we have brass stopper, and we want to remove the stopper easily. So technically alpha of brass is greater than alpha of steel. So if you are changing the temperature of this two substance by delta T, let's say you are increasing the temperature by delta T, expansion in the brass will be more and expansion in the steel will be more. So it will not help you. Brass will expand more, so it will be now more tighter than the previous one, right? Expansion in brass stopper will be more as compared to the expansion in the steel. So it will be more fitter than the previous one, right? If we cool it down, let's say we are decreasing the temperature by delta T, because of the more value of alpha of brass, it will contract more. Its length will decrease more. The change in length for brass will be more as compared to the steel. If brass is decreasing by 1 centimeter, then the steel will decrease by approximately 0.8 centimeter, 0.9 centimeter. So brass will decrease, the length of the brass will decrease more, and because of that it can be loosen up from the steel pipe, right? So yeah, it should be cooled, not be heated. So correct answer is option 2, right? Next is question number 31. We have a steel rod of length 4 centimeter in cross-sectional area 4 centimeters square, is tightly fixed between two supports and is not allowed to expand. Okay, it is heated through 2 degrees Celsius. The thermal stress developed is dash 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 into 10 power 6 Newton per meter square. We need to find the value of dash 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 over here, right? So this is rigid support, and we have this rod in between these two rigid supports. We are not allowing it to expand. That means there will be some stress and strain developed in the body, right? Strain is delta L upon L, which is delta L can be written as L alpha delta T divided by L. So it is alpha delta T. This is strain, right? Stress is Young's modulus into strain, which is alpha delta T in this particular case. Young's modulus is 20 into 10 power 10. Alpha is 18. It's not 1.8, it's 18 into 10 power minus 6, and change in temperature is 2 degree, right? So it is 18 into 2, 36 into 20, 720 into 10 power 4. So you can write it as 7.2 into 10 power 6 Newton per meter square. So value over here should be 7.2, which is option 1. Question number 32. A meter rod made of steel is correct at 0 degrees Celsius and other meter rod of same material is correct at 30 degrees Celsius. If alpha is 12 into 10 power minus 6 degrees Celsius inverse, the difference between their lengths at 20 degrees Celsius is. So let's say we have meter scale. So initial length of this scale at 0 degrees Celsius is 1 meter. Of this scale, it is 1 meter at 30 degrees Celsius. Okay. Now we are making the temperature 20 degrees Celsius. So its temperature is increasing from 0 to 20 degrees Celsius. So it will expand. Okay. So new length L1 dash will be L into 1 plus alpha, that is, let's say it is alpha delta T, change in temperature. For this one is 20. For this one, we are decreasing the temperature by 10 degrees Celsius. So it will contract. Its length will decrease, right? So L2 dash will be L into 1 plus alpha into 20 minus 30 minus 10, right? Okay. So change in difference in length will be L1 dash minus L2 dash, which is L plus alpha L into 20 minus L minus plus 10 alpha L. So this will cancel this. So we have 30 alpha L. Initial length is 1 meter. Alpha is 12 into 10 power minus 6 and L is 1, right? So this is 360 into 10 power minus 6. So we can write it as 0.036 centimeter, which is option 3. Yeah. Question number 33. A thin copper wire of length L increases by 1% when heated from 0 degree to 100 degrees Celsius. That means delta L upon L into 100 is equals to 1. We have a thin copper plate of area 2L into L, that is 2L square, is heated from same temperature 0 to 100 degrees Celsius. The percentage increase in the area of the plate will be. So percentage increase delta L upon A is equals to 2 times delta L upon L for small percentage changes, right? You can apply this one, right? So it is 2 into, if you multiply it by 100, you can get percentage change. So it is 2 into percentage change in length, which is 1. So it will be 2%. Okay, which is option 4. Next is question number 34. A crystal has coefficient of linear expansion alpha 1 as 13 into 10 power minus 7 degrees Celsius inverse and alpha 2 in a direction and 23.1 into 10 power minus 7 degrees Celsius inverse in every direction at right angles to it. Okay. So you can write gamma is equals to alpha 1 for one direction, alpha 2 for another, and alpha 2 for another. So it is alpha 1 plus 2 alpha 2. This is our gamma. If the volume of the crystal is 10 power minus 6 meter cube, find the change in its volume if its temperature is increased by 100 degrees Celsius. So delta V is equals to V naught gamma delta T. V naught is 10 power minus 6. Gamma is alpha 1 plus 2 alpha 2. So it is 13 into 10 power minus 7 plus 2 times 23.1 into 10 power minus 7 into delta T is 100. Right. So if you solve this one, you'll get change in temperature as 3.92 into 10 power minus 1 millimeter cube, which is option 1. Question number 35. 2 point charges, each 10 power minus 6 coulomb, are placed at ijk meter and B at 2I cap plus 3j cap plus 3k cap meter. The force between these two charges is. So let's find the separation between these two charges. So that is equals to 2I cap minus I cap plus 3j cap minus j cap plus 3k cap minus k cap. I'm finding the difference between these 2 points, the distance between these 2 points, right? So it is uh, b ka position vector minus position vector of a. So this is I cap plus 2j cap plus 2k cap. So this is the r vector. Let's find magnitude of r vector. So it is under root of 1 square plus 2 square plus 2 square. So it is 8. 4 plus 4 plus 1, 9, which is 3. Okay, fine. Now force is kq1 q2 upon r square. K is 9 into 10 power 9. Q1 is 10 power minus 6. Q2 is 10 power minus 6 divided by r square is 3 square, which is 9. So this will cancel this. So we have 10 power minus 3 Newton as the force, which is option 4. Question number 36. A simple pendulum of length 1 meter is taken to a height r from the surface of the earth. What time period of small oscillation of the pendulum at that point is? So length of the pendulum is 1 meter. That means it is seconds pendulum, right? So time period on the surface of the earth is 2 seconds. New time period t dash will be 2 pi under root L upon g dash. We are not changing the length. We are changing the value of acceleration due to gravity by taking this pendulum above the surface of the earth at a height r. Okay, so new g will be g dash, which is g upon 1 plus h by r whole square, right? So it is g upon 1 plus h is r divided by r whole square, so it is g by 4, right? So it will be 2 pi under root L upon g by 4, which is equals to 2 times 2 pi under root L upon g. Okay, but the value of this one is equals to 2 seconds on the surface of the earth, right? So it is 2 into 2, that is equals to 4 seconds. So correct answer is option 3. Question number 37. The value of acceleration due to gravity on the surface of the earth is x. Okay. At altitude of h from the surface of the earth, its value is y. G dash is y. If r is the radius of the earth, then the value of height is. So g dash is equals to g upon 1 plus h by r whole square. Right, so it is equals to x upon 1 plus h by r whole square, which is equals to y. Okay, so you can write 1 plus h by r whole square as x upon y. So 1 plus h by r is under root of x upon y. Okay, so h by r is under root of x upon y minus 1, right? So from this, we can find h as r into under root of x upon y minus 1, which is option 1. Question number 38. The magnitude of gravitational potential energy of a body at a distance r from the center of the earth is v. Okay. So we need to find magnitude of gravitational potential energy, which is Gmm divided by r, and that is equals to v. Its weight at a distance 2r from the center of the earth is. Okay. So weight is mg dash, right? Where g dash is the acceleration due to gravity at a distance 2r from the center of the earth. So it is m. G is gm upon r square, which is 2r square, which is 4r square. Okay, and it should be w. Okay, so you can write this one as gmm is equals to vr. So you can write gmm upon as vr. So it is vr upon 4r square, which is w. So this will cancel this. So we have w is equals to v upon 4r, and that is option 2. Question number 39. A simple pendulum has time period t. The bob is given negative charge and surface below it is given positive charge. Okay, so this is our surface. It is given positive charge like this. And the bob of the pendulum, which is over here, it is given negative charge. Okay. So because of the presence of positive and negative charge, electric field will be there. Okay, है ना? And we need to find the new time period of this one. So in this case, time period t initial without the presence of any charge, it is 2 pi under root L upon G. Okay. Now in this case, what happens is because of the presence of positive charge just below the bulb, it will be attracted by this positive charge. Okay. So apart from mg, at equilibrium position, it will have one more charge that, one more force, that is the electrostatic force in this direction. Okay, so this is Fe because of the presence of positive charge. So G effective will be mg plus Fe divided by m, which is G upon Fe by m, right? So new time period T dash will be 2 pi under root L upon G effective, which is G plus Fe by m. Now G effective increases, it is more than G and it is in denominator, right? So overall time period will be less than the original one. Okay, so correct answer will be option 1. Question number 40. Two particles undergoing SHM of the same amplitude and frequency along the same straight line, they pass one another when going in opposite direction each time when their displacement is half of their amplitude. Okay. A by 2, but direction is opposite. What is the phase difference between them? You can assume that the first one is, equation is this one, A into sine phi 1, and for second one equation is this one, A into sine phi 2. So phi 1 minus phi 2 or phi 2 minus phi 1, you can find the phase difference, right? So x1 is A by 2 for the first particle. Let's say it is going in this direction. A sine phi 1. So sine phi 1 will be 1 by 2. So phi 1 is pi by 6, that is equals to 30 degree, right? Now another particle at the same displacement with the same amplitude is going in the opposite direction. That means A by 2 is equals to A sine phi 2. So in this case, sine phi 2 is again 1 by 2, but phi 2 will be 150 degree in this case because it is going in the opposite direction, right? So phase difference will be phi 2 minus phi 1, which is 150 minus 30, which is 120 degree, which is option 4. Question number 41. Two masses, 8 kg and 4 kg, are suspended together by a massless spring of spring constant 1000 Newton per meter. Okay. When the masses are in equilibrium, 8 kg is removed without disturbing the system. The amplitude of oscillation is. Okay. So initially, let's say what is the extension? X1. So Kx1 is balanced by mg. So it is 1000 into x1, which is balanced by mass of this plus mass of this into g. So this is 12 into g. You can take g as 10. So x1 is 0.12 meter. Okay. Now when 8 kg is removed, only 4 kg will be there. So in this case, new equilibrium position will be at x2. So it is 1000 x2, which is equals to 4g, which is 40. So x2 will be 0.04 meter. So amplitude of the oscillation will be x1 minus x2, which is 0.12 minus 0.04, which is 0.08 meter, and that is option 2. Question number 42. A body is released from height phi r when r is the radius of the earth. Then that body reaches the ground with a velocity equal to. Okay. So this is the surface of the earth. It is released from a height of phi r, and from center its distance will be 6r. Phi r plus r, 6r. Okay. When it is released, its kinetic energy over here is 0. Only potential energy is there, which is minus gmm divided by r plus h. So it will be 6r. When it reaches to the surface of the earth, its kinetic energy will become half mv square and potential energy is minus gmm upon r. So this is the total mechanical energy and this is the total mechanical energy. So mechanical energy is conserved throughout the motion. So you can write minus gmm upon 6R is equal to final mechanical energy half mv square minus gmm upon r. Right, so it will give you gmm minus gmm upon 6R is equals to half mv square. So we have 5 gmm upon 6R, and that is equals to half mv square, cancel. So we have 5 gm upon 3R is equals to v square, and gm can be written as gr square because g is gm upon r square. So capital G, capital M can be written as small g into r square. So this is 5 gr square divided by 3r is equals to v square. R are cancelled, so we have V is equals to under root 5 GR divided by 3, which is option 1. Question number 43. A steel ball initially at a pressure of 10 power 5 Pascal is heated from 20 degrees Celsius to 120 degrees Celsius, keeping its volume constant. Find the pressure inside the ball. Coefficient of linear expansion of steel is this, and bulk modulus of the steel is given this. Okay. So delta V is V naught gamma delta T, and you can write it as V naught into 3 alpha delta T. Bulk modulus is P upon delta V upon V. So you can write delta V upon V is equals to gamma delta T. So P upon gamma delta T is equals to bulk modulus. So pressure is bulk modulus of gamma delta T, right? So bulk modulus is 1.6 into 10 power 11. Gamma is 3 alpha. So this is 3 into alpha. 12 into 10 power minus 6 into delta T, that is 100. 20 to 120, 100 degree. Right. So pressure inside the ball will be 5.8 into 10 power 8 pascals. Okay. All right. Okay. Next is question number 44. Solids expand on heating because kinetic energy of atoms increases, potential energy of atoms increases, total energy of atom increases, and potential energy curve is asymmetric about the equilibrium distance between neighboring atoms. So correct answer is option 4. If you look at the potential energy curve, okay, so it is something like this, and you can see that this is asymmetric about the equilibrium distance between neighboring atoms. Let's say at equilibrium position, this is the mean position of the vibration of the atoms, right? Oscillation of the atoms are not. As potential energy increases, the mean position, the average mean position shifts. And now this is the new mean position, R1. As again further increase the potential energy, this is the new mean position, R2. And you can see that R2 is greater than R1 is greater than R0. So because of the increase in the average, distance between mean positions, right, because of the increase in potential energy, solid tends to expand. So correct answer is option 4. Question number 45. A uniform brass disc of radius r and mass m is set into spinning with angular speed omega naught. So its initial moment of inertia is m r square by 2 and angular speed omega 1 is omega naught. About an axis passing through center of the disk and perpendicular to the plane of the disk. Okay. If the temperature of the system increases from theta 1 degree Celsius to theta 2 degree Celsius, so change in temperature is theta 2 minus theta 1 without disturbing the disk. What will be its new angular speed? Okay. So we are not disturbing the disk. That means we can conserve the angular momentum. So I1 omega 1 is equals to I2 omega 2. So omega 2 will be I1 omega 1 divided by I2. Our moment of inertia will change because we are increasing the temperature of the body, right? So in this case, R will change. So I2 will be m by 2 R dash square. R dash is the new radius at temperature theta 2. So you can write this is m by 2. R dash square is R into 1 plus alpha delta theta, that is theta 2 minus theta 1 whole square, right? So this is m by 2 r square into 1 plus 2 alpha theta 2 minus theta 1. You can use the approximation for small values of alpha, right? So This is the new value of I2, right? And mr square by 2 is I1. So I2 can be written as I1 into 1 plus 2 alpha theta 2 minus theta 1, right? So it will be I1 omega naught divided by I1. I2 can be written as I1 into 1 plus 2 alpha theta 2 minus theta 1, right? So I1 cancel. So new value of omega is omega naught divided by 1 plus 2 alpha into theta 2 minus theta 1. So correct answer is option 3. Question number 46. Two charges 4E and E are at a distance x apart. At what distance a charge q must be placed from the charge E so that it is in equilibrium? So let's say it is kept at a distance y, so remaining distance will be x minus y. Right, so charge is in equilibrium. That means force exerted by this 4E should be equal to force exerted by this E. It should be equal and opposite, right? So that net force will be 0. So force on charge Q due to small e will be K Q E upon y square. And it should be equal to force on charge Q due to 4E, which is K 4E into Q upon x minus y whole square. So KQE will cancel each other. So we have x minus y whole square is equals to 4y square. Take the square root on both the sides. So you'll get x minus y is equals to 2y. So 3y is equals to x and y is equals to x by 3. So separation should be x by 3 from E. Correct answer is option 3. Question number 47. A particle of mass m and carrying charge minus q1 is moving around a charge plus q2 along a circular path of radius r. Okay. So this is minus q1 and radius is r. Mass is m. The period of revolution of the minus q1 about plus q2 is. So centripetal force is provided by the electrostatic attraction over here, electric force, right? Which is K q1 q2 upon r square, which is equals to 1 upon 4 pi epsilon naught q1 q2 upon r square, which is equals to m omega square into r. So you can write omega square as q1 q2 upon 4 pi epsilon naught r cube. Omega is 2 pi by t. So you can write it as 2 pi by t whole square is equals to q1 q2 upon 4 pi epsilon naught r cube. Take the square root. So 2 pi by t is under root q1 q2 upon 4 pi epsilon naught r cube. So t will be 2 pi under root 4 pi epsilon naught r cube divided by q1 q2. Right, so you can take this pi inside and 4 outside. So it will be 4 under root pi cube epsilon naught r cube divided by, also we have m also over here, m into m divided by q1 q2. Right, so correct answer is option 1. Question number 48. Two pith balls, each of mass 30 mg, are suspended by two threads from a support. When the charged identically, the pith ball move apart by 0.08 meter. The threads making an angle 60 degree with each other. The charge on each pith ball is. So this is the situation now. We are providing equal charges Q and Q, and because of that these two balls move apart and the distance is 0.08 meter. Right, so if you look at first ball, it will experience mg in downward direction, tension over here, right? And this was the electric repulsion, and 60 degree with each other. That means each angle is 30 degree. Okay, so this is 30 degree, right? So you can write T cos theta is equals to mg, and similarly T sin theta component is k q1 q2 upon r square. So if you divide this two, you'll get cos theta upon sin theta, that is cot theta is equals to mg upon kq square upon r square, right? So kq square upon r square will be mg tan theta. So q square will be mg r square tan theta upon k, right? So if you put the values of each and everything, like q is under root mg r square tan theta upon k. If you put the value of m is 30 mg, g is 9.8, r is 0.08 meter, tan 30 degree is 1 by root 3, and k is 1 upon 4 pi epsilon naught, which is 9 into 10 power 9. You'll get the value of charge is 10.9 nanocoulomb. 49. A pendulum clock fitted with a small heavy bob that is connected with a metal rod is 5 seconds fast each day at a temperature of 15 degrees Celsius. Okay. And 10 seconds slow at a temperature of 30 degrees Celsius. The temperature at which it is designed to give correct time is. So basically, when the temperature is 15 degrees Celsius, it is 5 seconds fast in 24 hours. Okay. It is 5 seconds fast. मतलब clock is running fast. That means its time period is less. Time period is 2 pi under root L upon G. If time period is less, that means length is decreasing by changing the temperature. So in first case, actually the temperature of the pendulum is decreasing from, let's say, some temperature T to 15 degree. In second case, when it is at 30 degree, it runs slow, right? Slow means its time period is more now. So its length is increasing by changing the temperature, right? So if length is increasing, that means its temperature is more, okay, than the previous one. So basically in the second case, temperature is changing from T to 30 degree. Okay, it is increasing, right? Okay, so we need to find the temperature at which it is designed to give correct reading. So time lost in or gained in one day is given as half alpha delta theta into t, that is time in time period of one day, that is 24 hours, right? So for the first one, phi is equals to half alpha change in temperature is we are decreasing the temperature, so it is t minus 15 into delta t, that is 24, is equals to this one. Okay, and for the second one, 10 is equals to half alpha 30 minus t into 24. So let's divide this one. Okay, delta theta is t minus 15 for the first one, 30 minus t for the second one. T is 24 hours because it is given in a day, right? Alpha is the coefficient of linear expansion. So this will cancel this will cancel this. So we have 1 by 2 is equals to t minus 15 upon 30 minus t. So 30 minus t is equals to 2t minus 30. So 3t is equals to 60 and t is equals to 20 degrees Celsius. So it is designed to give correct reading, correct time at 20 degrees Celsius, which is option 2. Next question is, on a smooth inclined plane, a body of mass m is attached between two massless springs. The other end of the springs are fixed to form supports. If each spring has force constant k, the period of oscillation of the body is. So basically, one end of the string, each spring is connected to the block and other is connected to the support. That means these two springs are in parallel between two common points, right? So K effective in parallel combination is K1 plus K2. In this case, it is 2K, right? So time period is 2 pi under root m upon K effective, which is 2 pi under root m upon 2K. So correct answer is option 1. So that is it for today's session. Thank you so much, guys. Take care, everyone. Bye bye.